Today's video representations largely operate just on image data, but videos contain audio too. Here we propose to learn a multisensory representation that jointly fuses audio and visual information. We learn this representation through self-supervision by training a neural network to predict whether a video's audio and visual streams are temporally aligned or synthetically shifted. We use the representation that we learn in 3 applications: visualizing the locations of sound sources, audio-visual action recognition,
and we're going to cut this,
and separating the sounds that are occurring on screen from those in the background. Here's an example where we separate the speech of a Japanese speaker from that of their English translator.
Were able to show to the rest of the world the unshakable Japan-US alliance.
Thank you so much.
Thank
揺るぎない絆を世界に向かって示すことができたと思います。Thank you so much.
Were able to show to the rest of the world the unshakable Japan-US alliance.
We'll now discuss these applications in detail. We can use our representation to visualize the locations of sound sources, or sound-making actions, by viewing the parts of the video that the network devotes the most attention to. We do this by modifying the network to compute a 3D class activation map. In particular, we can look at videos in a held-out set that the network is most confident about. We see qualitatively that the network responds to faces and speech. What about actions besides speech? To study this, we visualize the top responses for videos taken from different categories of the kinetics dataset. We show some of these here, after removing face and speech activations, which are common to all categories. We can also apply our representation to action recognition. We do this by initializing the weights of an audio-visual action recognition network with the features that we learned through self-supervision. Or we can remove the audio features and just use the image features. We evaluated our representation on the UCF 101 dataset, where it outperformed other self-supervised methods. Please see our paper for more details. Finally, we use a representation for audio-visual source separation. To do this, we augment it with a second network that separates an input spectrogram into 2 components: the sound that's occurring on-screen and the off-screen sound. During training, we synthetically generate off-screen sound by adding a random audio track to that of our input video. Here are some results on real-world audio mixtures.
Asking about them because they're not interesting facts to you.
That's not true. I have plenty of questions on immigration. You've attempted to filibuster by talking about your flights with the president.
No, I'm not. Asking about them because they're not interesting facts to you. And there were some people. No, I'm not. I want to.
That's not true. I have plenty of questions on immigration. You've attempted to filibuster by talking about your flights with the president.
No.
Presented progress towards quality education for everyone. Presented progress towards quality education for everyone.
We can also use our model to separate the laughter of a studio audience, despite the fact that it wasn't explicitly trained for this task.
All right. Okay. All right. Okay.
To see how the output of our model varies with the input video, we can take a video where multiple people are speaking at once.
You're saying that
No, let me finish my question.
And we can visually mask one of the speakers and ask our algorithm to predict the on-screen sound.
You're saying that they're not true.
We can also do this with the other speaker.
No, let me finish my question.
Finally, for the remainder of the video, we show the model's results on a random sample of synthetic mixtures from our test set.
Gets killed in the first 5 minutes, and then gets killed in the first 5 minutes, and then gets killed in the first 5 minutes, and then
but I really want it to be here. But I really want it to be here.
I have another Chinese movie gonna be
I have another Chinese movie gonna be. I have another Chinese movie gonna be.
They have somebody in their head. They have somebody in their head. They probably.
Dunkin' Donuts job. I mean, it is a book. And I memorized Dunkin' Donuts job. And I memorized Dunkin' Donuts job. And I memorized. You can tell. I mean, it is a book. You can tell. I mean, it is a book.
Ich glaube, es ist schwierig, dass das so. Ich glaube, es ist schwierig, dass das so. Ich glaube, es ist schwierig, dass das so.
Right. I mean, they're so sweet and so. Great. I mean, they're so sweet and so.
That happening to me is so remote. That happening to me is so remote.
I heard about this and I thought, well, and all. I heard about this and I thought, well,
so remote. That happening to me is so remote that I.